Hello guys, I'm Kaustubh Kushagra from CSE third year, and for this team I am going to be the research and prior art team. Thank you.
Hello guys, this is Ritesh from CSE third year and I'm working on the hardware and sensor part of this project.
Hello, this is Lukesh. I'm working for the embedded firmware and the edge computational part for this group.
Hello, this is Priyani, and I'm working with the solution architecture for our project. Thank you.
Hi everyone, I'm Astos Padi and this is our problem statement for SIH26008 intelligent monitoring and prediction of conveyor belt joint rupture and damages in iron ore mining industry. So in current day scenario, iron ore mines run a kilometer long conveyor belt. There are two things that generally kill them. Splice. First, a belt isn't a single loop. It is sections that are joined together and the joint itself is the weakest link among them. It falls under full tension and snaps back, generally killing people in the process. And next is the puncture. A sharp rock punches through the cover undetected. The hole slits hundreds of meters of the belt. So today's inspection methods generally include a manual inspection that is done by the people, and there's this magnetic flux method. What we have built is we have built an autonomous multi-sensor conveyor health system, 3 channels watching the same belt. First is the laser LDR, next is an accelerometer, and third is a camera with CNN for tracking the damages and the belt. We use Raspberry Pi as a brain, connecting all of this and running the whole system offline with no cloud inference or APIs.
Solution for those exist, right? Yes, they do exist and we have read about them, ranging from a 48-year-old magnetic splice detection to the current standard, which is magnetic flux leakage. And we did not make any of those for a few reasons, because most of the iron ore plant belts in India are made of fabric, ply, and MFL reads nothing on them. It sees the core, not the cover. A fresh puncture is invisible to it. And it's a scanner, not a guard. It tells you the belt is dying next month. It does not cut power while the motor is ripping it right now. The gap is what we built into giving it flexibility to the users. Thank you.
Four things. Belt agnostic, nothing embedded, no cords needed, and works where MFL physically can't. Protective and diagnostic in one box. Vibration trends predict splice failure. Laser penetration trips the motor in milliseconds. And then let's get on to the decoupled safety logic. And this is the real problem that nobody solves. Existing systems fall slip, operators bypass them, and they stay bypassed forever. So vibration never stops our belt. It only raises a maintenance warning. Only verified laser penetration triggers an e-stop on 2 or 3 channel agreement. And then let's get on to the cost. Imported systems are 15 lakh per conveyor. So a plant protects 3 belts out of 60. Our BOM is under 25,000. All 60 get protected.
Hey, this is Lukesh. Currently, I am going to show the working process of our prototype for the project. In this project, we are using an ESP32 as the brain of the project. We have a display unit, a TFT display. We have gyroscope over here to measure the vibration level. We have 3 beams. Those are connected serially. For measuring the intensity of the light, we have LDR sensors here. So how our project will be working. Over the display, we can observe a straight line. In this graph, we can observe a straight line. This is representing that there is currently no vibration over the gyroscope. If I tap the gyroscope, we can observe the graph has changed and the spike have arisen on it. And currently we observe the status is normal and the light intensity is at 0%. The LDR sensor will be placed in between the conveyor belt, and over it we will be placing these laser beams. For an example, if the conveyor belt is damaged or ruptured, and due to which the light can pass through it. So if the light passes through it, then this LDR sensor will be activated and the light intensity will be increased. So let's assume that the light passes. As we observe, the light intensity goes to 69%. Then we got a warning that belt is ruptured. And what's the working of this gyroscope? This gyroscope will be directly attached to the motor. If there is any rupture in the belt or there is a damage in the belt, then it will show abnormal vibrations, and the vibration can be observed in the graph, and then again we will be getting a warning that the belt is ruptured. So we will be placing over the conveyor belt, and the working will continue.